So our next speaker is Doug Plata. So Doug is a medical doctor. He is the head of the Space Development Network, which is a volunteer space project organization that is one of our partners, and we're very excited to be working with. And Doug is going to talk about analog moon bases here on Earth.
Great, thank you. And let me just say, I've long been a big fan of Maston Space Systems. Dave Maston himself and the whole team there at Mojave. I had a chance early in my space advocacy career to go and visit them. And I actually got to go in and see and touch the couple of Centaur stages they had on loan from United Launch Alliance. And boy, just wish that Zeus or Aces would have been proposed as a lander. So go for it.
You never know. I would say right now it's
really
it's still on the roadmap. It doesn't have the funding. I haven't forgotten. Don't worry.
Well, it could have had funding if it applied to NASA, but anyhow, that's another story for another day, I suppose. Okay. So yeah, I'm a urgent care physician, and very much into space advocacy, and just have really been enjoying myself. I did go ahead and start the Space Development Network, which I'll explain a little bit more. But the topic of my presentation this morning is about the need for a new type of analog base. And let me just go ahead and turn on. I've got a PowerPoint presentation that will take us to about 15 minutes before the end of the hour, and then I'll open it up for questions. Feel free to post some questions in the chat, and I'll be glad to go ahead and tackle those.
It'd be in the Q&A, actually, the Q&A tab for everyone.
Q&A, okay. So yeah, the need for a new type of analog base, and I'd just like to encourage all of you to go to the Space Development Network's website. It's DevelopSpace.info. It is full with content. Actually, I went through and found that it would take about 8 hours to go through and read every page. Almost every aspect of space development, actually exploration, development, and settlement are addressed in specific pages throughout the website. So go ahead and check it out at DevelopSpace.info. So let me, like they did in, in college when we had speech class, you're supposed to tell them what you are going to tell them, and then you tell them, and then you tell them what you told them. So let me go ahead and give you the overview. I want to go ahead and lay out for you what I think are the probable phases of how we're going to go from even cargo landings on the moon through initial habitat. I believe there will be an international phase, and then in ultimately private settlement. And I'd like to lay it out for you because I think that we can see initial settlement, the first settlers going to the moon indefinitely. I think that could be sooner than most of us here would anticipate. So it's exciting, and it's for that reason that I think we need to have a new type of analog base that illustrates what that process might look like. So it would be a new analog base, which I'm terming the Moon-Mars Analogue Base, because there's so much overlap between development and settlement of the Moon and Mars initially. And then I'm going to make a distinction between sort of the exploration-oriented analog bases that are very common and this sort of new approach of focusing on development and even aiming towards settlement. That is what the orientation of the Moon-Mars Analogue Base would be. I also am advocating that this new analog base not be located in a rural area, a very remote area, but rather so that it can develop quickly, it can have a local support team within a local city, that it should be near a large city, it should be highly visible, and have routine development work being done on it. I think that there should be a master plan to the development of the Moon-Mars Analogue Base that is flexible, but has a guidance for where this base is heading. And then the activities at the site, I mentioned the idea of sort of weekend work bees using the local supporters, but also I think there's a place for possibly summer sessions. These would be dedicated periods of time that perhaps university students could come out and focus on one project and really take it from beginning to end within a short period of time. And now, in terms of the size of the Moon-Mars Analogue Base compared with other analog bases, what I'd like to suggest is I think it's within reach that we could have a rather large base for fairly cheap if we use sheet plastic, which I'll explain. And I think that what we can do is we can illustrate not just a single habitat or maybe a habitat in a greenhouse, but really the full spectrum of what a permanent base should have heading towards settlement. I'm going to really emphasize the great value of inflatables as initial habitats. And I think that they could be very cost effective, not only for the Moon-Mars Analogue Base, but actually on the Moon and on Mars. And the construction, I'll put that in quote, constructions of these inflatables would be extremely rapid. You could inflate them in an afternoon. And then I'm going to go ahead and mention sort of three categories. I'm going to mention a MiniHab, which is something that I actually constructed this last week. So I'll show you pictures of that. And then the concept of a UniHab, or the initial habitat that contains everything that the initial crew needs. And then after that point, then there would be a set of specialty Habs that gets into specific functions. So the vision that I'd like to lay out in this presentation is that I would like to see the Moon-Mars Analogue Base be a joint project between multiple space advocacy organizations and university people and others, as well as just common space advocates like you and me. And then I think the purpose of the Moon-Mars Analogue Base would be to illustrate and to promote a specific vision to the space, the decision makers, both the public through the PR, but also decision makers, whether they're in government or even industry, and possibly philanthropic donors as well. And then I'm going to mention about how I think that we could have a really rapid development of a fairly large analog base that would illustrate to the people as we get media exposure that settlement, at least on a small scale, is very doable, and we would be illustrating how that could be done, and hopefully generate some discussion and people questioning as to whether, in fact, is this vision realistic? And then also the Moon-Mars Analogue Base, I think this sort of fundamentally would be a location where various space advocates, not just local advocates, but people wanting to help develop it, then they can work at home wherever they are, be able to send files that can be 3D printed or machined or whatnot, and really help advance the different aspects of the Moon-Mars Analogue Base. So I got a lot to cover, so let's jump right into it. So how soon do we expect that a permanent base could happen on the Moon? Well, obviously we have the Artemis program and plans. 2028 is the idea of having essentially permanent access to the Moon, and I think a permanent facility, although maybe not manned continuously. But if you take a look at other organizations, well, let me just say that SpaceX's Starship, it was mentioned in the previous presentation that Starship changes everything. It truly does. If you can get Starship to orbit and you can refuel it, then you could go ahead and deliver up to 100 tons of payload to the lunar surface per mission. And I think that this is something that governments are not going to ignore. There is going to be a public-private partnership if we can get Starship to orbit, or SpaceX gets Starship to orbit. And so when is Starship going to get to orbit? Possibly within a year. And when would it land? Perhaps a few years later. I think that we could be looking at sizable payload being delivered to the lunar surface in a relatively short period of time. And when you have sizable payload, then you can really think beyond just sort of sorties, exploration for scientific purposes, and you can really begin to think in a big way about a permanent base And the difference between a permanent base and an initial settlement is not that big a difference. Both need life support, both need habitats, both need power, these sorts of things. So I see any permanent base established for any reason is going to facilitate private individuals going and remaining on the moon indefinitely, which is my definition of settlement, the beginning of settlement. So let me go ahead and discuss the phases from cargo. I'm talking mostly large cargo all the way through settlement. So this is my understanding of how things are likely going to go. So we are going to have cargo, and probably during this phase, there is going to be telerobotic operations, especially targeting the ice on the moon. From what I know from the data, I think that it's doable. I think it's a matter of just getting there, and relatively soon thereafter, I think we'll be able to overcome the 5 major environmental conditions in the permanently shrouded craters to be able to extract the ice and convert it into propellant. But during this cargo phase, the last thing before the crew phase would be to actually go ahead and deliver a habitat, and I have specific recommendations as to the nature of this habitat for an initial crew. So initial habitat, initial crew, and then following that would be what I call the international phase, and that is American phase first, because I'm advocating public-private program, NASA and SpaceX. So NASA's putting up most of the money, and so I imagine the initial base would be populated with American astronauts doing exploration. But then shortly thereafter, I think that governments typically have far deeper pockets than even very wealthy individuals, and so I think the first seats and the first tickets, the first people to go to the moon are going to be from governments around the world. And I believe that practically all governments would love to see their national astronauts, heroes, exploring the moon on behalf of their citizens in their own language and bringing their culture to the moon. And so I think there's going to be this interim phase that's going to be huge and really help to transition us from government support to private. And that's the next thing. As we have increased flight, if we have infrastructure, then it's really incremental development of the bases where the private settlement occurs. And I divide this into early settlers and later settlers. Early settlers are going, they're on a mission, they want to be part of this historic development. Later settlers, especially their spouses, I think, are going to have quality of life issues, and so the base is going to be able to have to provide some of these things to attract the later settlers. And then as the population grows, I know this is a bit far out there, but we should start thinking about it actually. As the base grows and we have older sort of retirees who maybe cannot learn the common language, such as English, then I think that there's going to be sections of the international base that are going to be the Portuguese section, and then the Russian section, the Arabic section. When it gets large enough, I think these people are going to say, hey, why don't we start our own colonies in which, you know, the language spoken is our language. And I think this is beginning the process towards political independence. Again, that's a bit out there. I mean, that's probably decades away. So how would the Moon-Mars Analogue Base be different than the current analog bases? Well, most all of the analog bases are sort of exploration oriented. It's sort of, you know, Apollo over again, this time on Mars. Whereas what I'm advocating is the focus of the Moon-Mars Analogue Base would be development and settlement, as I keep saying. Also, the Moon-Mars Analogue Base needs to be lunar inclusive, unlike most all of the, not all, there's a couple that have lunar aspects, but most all are actually Mars oriented. And I think the moon deserves some love. So this is why I call it the Moon-Mars Analogue Base. That would be applicable to both situations. How is the Moon and Mars different? I'm not going to go through these in detail. This is just my list. I think they're different. In fact, I'm going to go ahead and highlight a couple things here, a few things. The resources are different, and so the analog bases would have to be different. For example, Mars is probably going to be really taking advantage of that very handy atmosphere with carbon and nitrogen, and I would anticipate plastic would be a major resource on Mars, but not on the Moon. On the Moon, it's going to be mostly metals, and so there's that significant difference. However, similar, perhaps the same, would be habitats between the Moon and Mars. This is what I'm advocating, is that we first get access to the Moon and we employ the concepts developed in the Moon-Mars Analogue Base, and then we know SpaceX is you know, making a beeline for Mars, and so they're going to go ahead and try to land cargo on Mars. If they can successfully do that, then they're going to try to go ahead and land crew. But what are we going to do when we get to the Moon, and what are we going to do when we get to Mars, especially Mars, where people have to stay there for a long time, years, before they can even return? And my thought is that the habitats employed on the Moon, this is a great opportunity to reapply these proven approaches on Mars, and so I see a lot of synergy there. I think also growing the food, this is debatable, but I think they're going to use the same processes both on the Moon and Mars. And shielding is on Mars, yeah, you have a little bit of atmosphere, but I think that it is covering it with Regolith. Telerobotic covering of habitats with Regolith is the way to get down the GCR millisieverts, the energy on the crew. And then spin gravity using an indoor centrifuge. In my estimation, my educated guess is that the Moon and Mars are going to use indoor centrifuges and getting up to full Gs for several hours a day. And I think that it's going to be the same on both, because I think there is some suggested evidence on RAP models that even Mars gravity is not going to be sufficient. There's going to be some health problems there. And then funding, I actually think that sort of surprisingly, funding of lunar development and Mars development is going to follow the same trajectory. I think it's going to be government funding initially. There will be this international phase of purchasing seats to go on missions and be able to stay at a permanent and expanding base. And then private funding is largely going to be people savings. I think Elon is correct. People older, they have had time to save up, they're freed from child rearing responsibilities, from career responsibilities. And so I think savings is going to be the big source of revenue during private settlement. So another difference is, as I keep mentioning, is the difference of the Moon-Mars Analogue Base and others, is I see the Moon-Mars Analogue Base as being really a development and settlement oriented versus leaning so heavily on exploration oriented like the other analog bases do. Now, the government seems, they seem very careful to always mention exploration, and they sort of don't want to touch settlement. And yet, with Starship, I think settlement is in the picture, at least in initial settlement. And then the analog bases, as I mentioned, they also tend to be exploration oriented with a lot of EVAs. And so I see the Moon-Mars Analogue Bases actually focusing on developing capability and sustainability and ISRU, and growing not just example amounts of lettuce, but actually providing the full nutrition that's needed. This sort of stuff is what I would like to see the Moon-Mars Analogue Base focus on. And again, Starship really makes the big difference. Large amounts of payloads means that you can develop rapidly, especially on the Moon, where you can do 70 round trips with one Starship compared with Mars, which you can only use it once in that period of time. And so I see Starship as making a huge difference. Even if they don't achieve full reusability, I think just being able to refuel in low Earth orbit is going to provide tremendous amount of capability, and we're going to see a rapid growth of any permanent base on the Moon. All right, so what are some of the specific things that would be involved in development heading towards settlement? Certainly agriculture is going to be, I think, an important part of the picture. And I think we need to move ahead. We need to actually go ahead and develop a full-scale agricultural system that is looking at providing the full nutrition for the permanent crew. Also, life support. We need to focus on the extraction and production of life support chemicals, you know, air and water and these sorts of things, and recycling is a big part of that. Also, getting into to reduce the transport costs, we should look at the metals on the Moon and Mars. On the Moon, 1% of the highlands is unoxidized iron, and so there are some ideas about how we can go ahead and extract that. And since they are unoxidized, it's a matter of melting and separating and melting that, and then using it. Sheet metal would be extremely useful on the Moon. And then ultimately thinking about where is this leading in terms of settlement, particularly private settlement. Well, international settlement and private settlement too. And then in terms of the location of the Moon-Mars Analogue Base, I'm open as to where it could be located. I have done some work by Tucson, visited quite a number of times. Tucson is a favorable place in terms of who they have there. There's the Tucson L5 Space Society is willing to be involved in a Moon-Mars Analogue Base. There's a University of Arizona at Tucson. This is a very space and moon-friendly institution that sort of has a history going back to the Apollo program. And then you have, which I think is very important, you have the prototype lunar greenhouse project there at the university in the School of Agriculture, which I think shows the way towards providing full nutrition for a permanent base. And then you have, for what it's worth, you have Biosphere 2 there, and you also have a company like Paragon Life Support Systems. So there's a lot of things going on there. But I'm not stuck on Tucson. One could go ahead and take a look at where weather conditions are favorable, where it's sort of mild temperatures and not rainy so much. And this is a map showing where the good weather is, and surprise, 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 of course, California, where I live, has the best weather. And I would say, especially as you are towards the coast, sort of your Long Beach, UCI sort of areas, I think those would be particularly good. But even going up to like Santa Barbara, anywhere along there. Ideally, I'd love to have it associated with the university and all of the possibilities for collaboration there. So, rather important part, and that is, should it be local to a city or remote, like the analog bases tend to be? So this is an example. This is Devon Island. It's way north Canada. There's 2 analog bases up there, both Mars oriented. And to get there, you gotta fly in, and shipping cost for cargo and crew is extremely high. And of course, they can't work on it very much just because of the great expenses. Rather, I think the Moon-Mars Analogue Base should be located close to a Home Depot. I think it should be within view of like a freeway, getting high visibility, and local people to come out and work on that, and arrange work bees for local supporters, including university students working on projects, to go on out to the analog base and be working on different aspects according to the master plan for development. And then summer sessions, these would be sort of intensive sessions that would especially draw university students from different parts of the country, maybe the world, to go ahead and come together and focus on specific aspects like robotics, or specialty Habs or centrifuges, etc., and to really focus in and accomplish it in a very intensive sort of way. Now, rapid development. As I'm going to share, I think that it is possible to go ahead and create an analog base, at least to illustrate it, in a pretty fast and relatively low cost. And the development should be rapid, because I think we're running out of time, and there is a gap for leadership in terms of what we do when we get to the Moon and when we get to Mars. And so I think there's a place where people step forward and start articulating and illustrating exactly what this might be. I think that the development of the Moon-Mars Analogue Base should be planned and not ad hoc, meaning not just whoever wants to come and do sims, whatever projects they want to work on, that's fine. Rather, we would reach out to people and say, hey, we need to get this greenhouse completed. We need to get the machining and metallurgy and these different things done. And so we sort of have a plan and seek people to go ahead and fulfill the different aspects of the plan. And we'd need to develop some sort of extensive timeline for this, but be flexible as well. I also think the Moon-Mars Analogue Base should have a plan in which there are regular opportunities for PR exposure for journalists, space journalists, but also the general media. And I have come up with a series of what I think would be progress at the Moon-Mars Analogue Base that would generate at least local media interest and also interest in the space media, and at times actually in the general media. So we should have reporters there when we have the inflation of the UniHab, and to illustrate just how quickly inflatables can be set up. We should be able to give tours to journalists, showing them, you know, when the interior decorating is done, when the centrifuge is done, when the greenhouse is done, to come in and tour and see the progress being made. And then, yes, we would be more focused on development and that sort of internal work inside the habitats, but there would be some simulations. In particular, I think that I'd like to be able to simulate this initial crew, this potentially very historic crew that sell their homes on Earth. They move to the lunar habitat, the initial habitat, and they are staying there not for a period of rotation, because that risks the crew, the lives of the crew being sent to rotate, and it risks their lives as they return. And so I actually believe that crew should stay for as long as their biomedical indicators indicate. If they're losing too much bone mineral density, that's the criteria to go ahead and get into the fueled up lander and go ahead and take off. In 3 days, you're back on Earth. So doing a simulation with this very historic sort of crew, I think, would be pretty newsworthy. So big emphasis in my presentation today is the great value of inflatables. Inflatables are commonly used on Earth. They can be extremely large. They can be so large that they have soccer fields. You know, these are places like in Canada or Michigan where they have these sorts of things. Soccer fields, Olympic-sized swimming pools, even golf tee. There's a picture there of a golf tee. So when people talk about, oh, nobody would want to settle because you'd be living your life in a tin can and you'd be struggling to survive and, you know, produce your next breath of oxygen, trying not to starve to death, I think that is not thinking it through well enough. We can deliver very, very, very large inflatables to the lunar surface, even acre size per starship. And so the idea of having very large indoors areas, providing that quality of life that the later private settlers would desire, is something that can be done. And so inflatables, I think, are the easiest way for this to be done. In communication with the inflatables researcher or lead at NASA, she sent me these 5 layers and the amount of mass per square meter that each of these layers would be. So there would be a abrasion-resistant layer on the surface. There would be a abrasion-resistant layer on the internal area where crews walking around. And then there would be a restraint layer such as Kevlar that would hold the pressure. And then 2 bladders in case one ruptures, you have time to fix it before the second one does. And you see the masses there. With these masses, you can go ahead and calculate for like a flat roofed inflatable, just how big that footprint would be and fit within 100 tons of Starship. And we're talking very large inflatables, as you will see. Also, inflatables can have some really beautiful and creative designs. This is the architect Frey Otto and some of his concepts of using these sorts of shapes. So I think we could get really creative with inflatables. So let me go ahead and compare the inflatables with other approaches, such as rigid cylinders. Obviously, inflatables can be far greater volume for the final habitat compared with just rigid cylinders. I do acknowledge that the starfish ship itself could be a habitat initially. I still think inflatables are better even for the initial crew, because if you land it as cargo first and then have telerobots go ahead and cover it, you can have that shielding from the get-go, whereas trying to push regolith or only going into a storm shelter in your starship is going to expose people to a large amount of radiation, because galactic cosmic rays make up the vast majority of the millisieverts that people receive. 3D printing of habitats, terribly popular. A lot of NASA challenges, university challenges about great designs. I'm rather frustrated with the focus on 3D printed habitats to the exclusion, where inflatable habitats just don't get anywhere near the attention that I think they deserve. 3D printed habitats, if you are shipping the binder, that's a lot of mass. If you are not going to ship the binder, but you're going to use sintering, that's very energy intensive. And then if you're going to get a binder locally, like sulfur, for example, then you got a whole operation to set up of mining and transport and using of that. Whereas inflatables can be inflated in an afternoon, 3D printers would take a very long time and use a great deal of energy to be able to construct. And whereas you can use the very best material for inflatables because you're constructing on Earth, you can use Kevlar and other materials, and you can test it and make sure it's safe before you ship it. You know, are you going to be testing the 3D printed habitats? How thick do you need to make it in order to be the equivalent strength of what you can produce in inflatables on Earth before launching? So in my book, I think there's a place for 3D printed habitats. I just don't think it's very soon. I think the easiest way is just go ahead and design, construct, and ship and inflate inflatable habitats, and you're off to the races. The size of the Moon-Mars Analogue Base as compared to others, as I mentioned before, most other analog bases are rather small. Again, just a small team, exploration oriented. Whereas I'm suggesting the Moon-Mars Analogue Base grow to a large size, imagining a large number of people that would stay there, heading towards settlement. I would also like to see the Moon-Mars Analogue Base be a project of several different space advocacy organizations. I know that there's some space organizations that really don't have their own analog base, and so this could be an easy way to achieve that goal. And I think working together, we can bring together the space advocates to work on the different aspects of the project and use the strengths of the different organizations as we work together. I would like to include, I mean, I've reached out to people are just beginning to suggest the idea, but certainly no commitments at this point. But people at Moon Society, National Space Society, there seems to be some interest. And after this presentation, I look forward to going ahead and beginning that sort of formal discussions about could we actually go ahead and develop this Moon-Mars Analogue Base as a joint project. I would also like to include a Mars space advocacy organization and not just the Moon. So funding of the Moon-Mars Analogue Base, I really think it depends on the materials that are used. If we do just a very simple illustration, and that's using sheet plastic, then I think that is actually within the range of space advocates. I think we can fund it ourselves, and I'll show you the MiniHab that I constructed this last week and showing really how easy that is. But if we want to have something more durable, something more permanent, then I really think working with these companies that produce the children's bounce houses would be the way to go with vinyl. And at that level, we're talking low tens of thousands of dollars for each large habitat. Then I think that perhaps Indiegogo, perhaps the Space Finance Group can help with that. And we could generate the money to do it, perhaps using some mechanism like that. But if we really want to do it proper and using great materials like Kevlar, and have equipment that's really working and you know, sort of really advancing the state of what we're demonstrating, then I really think that we need sort of wealthy philanthropist and then also maybe SBIRs and sort of projects that could be based there. And I'm not suggesting any billionaire in particular, but I think if we, you know, the higher the level of reality, of realism, then I think the more we need to be getting into really high value donors. So let me go ahead and mention about what I envision as being the very first habitat at Moon-Mars Analogue Base, as well as on the Moon and Mars in reality. And that is what I'm calling the UniHab. The UniHab is called the UniHab for a couple reasons. Number one, it is a unified habitat. It doesn't have a separate greenhouse and separate living quarters, etc., but it's brought together all into one. And it's a UniHab because it has everything within it necessary to support an initial crew of 8. And so I developed just a very notional diagram of what could be included in there, and I'll go through in some detail as to the different sections of this. And there at the bottom, there's a cross section of what it would look like. It'd be sort of pancake shaped, and Telerobots would have pushed Regolith on top, providing the shielding, so that when crew arrives, it can walk into a shielded setting. Flat roofed, so that you don't have to 3D print the Regolith, do any centering to keep it on top. Instead, they just push it on as it inflates. There's tethers inside that keep the roof relatively flat, sort of like a air mattress. And this is, I think, the simplest approach that we can rapidly get full shielding for the initial habitat. Let me describe what I envision as the Telerobotic setup. So this is, forgive me, I'm not a good animator. Any of you who can help me with this, I'd appreciate it. But this is my PowerPoint illustration, and I think it's nonetheless gets the point across. So you have a lander that's developed, that's deployed or landed a packaged up UniHab. You cut the straps, open the valves on condensed air, and against the vacuum, relatively small amount of air, this thing's going to inflate and unfold, and voila, there you have unfolded your habitat. But what I would do is I'd actually go ahead and deflate it down flat so that Telerobots could go ahead and push Regolith from ground level to ground level on top of the habitat, and then you re-inflate the habitat, and then the Telerobots go ahead and push Regolith on the sides. Now what you've got, and on the moon, you've got 2.6 seconds round trip. And so I think this could be done strictly telerobotically even before crew arrives. So when crew arrives, you got a turnkey habitat, very large, and with everything that they need from the get-go. So what would be the components of the UniHab? 35% of the volume would provide enough calories and air processing, water processing for initial crew of 8. You would have the work done at the University of Arizona Tucson and their prototype lunar greenhouse project. I think we could use a lot of the work that they have done to, in fact, the 35% of the volume is I based it upon their work. Would we also have aquaponics? The Space Development Network, we have an agricultural working group, and our group looked at this issue, and we felt that probably the workload that maintaining fish initially is probably too much. We would wait until the base grows to maybe about 100 people before actually adding in that source of meat. So actually probably maybe tofu might be the source of quote meat initially, or protein in the diet. So if we want extended stay on the moon and Mars, we may want to go ahead and provide an indoor centrifuge. And I like this diagram here to the right because it's got these swivel chambers and it's very low mass, so it can be easily shipped up within a payload, assembled. It's got to have very strong anchor point in the center there, the axis. But this could be spun up, and crew would go in and do sedentary activities, if that's not an oxymoron. You can see the list there, and I actually got together with some space advocates, and we rode in our local Gravitron and went through 9 out of 10. I was actually trying to go to sleep and couldn't sleep even after being sleep deprived for 24 hours. But I'm pretty sure that even that could be done. But you know, a lot of screen time, things that we do, like right now, we are all sedentary probably, and so it would be times like this that you would spend in the centrifuge. As long as you don't turn your head, physics says you don't have any Coriolis effect. And when I was in the Gravitron, I closed my eyes, didn't move my head, and I couldn't tell that I was spinning around, could not feel those Coriolis effects. What it does is if you're standing upright in this thing and the chambers swivel out, so the force axis is down through your feet, it begins to simulate the hydrostatic pressure distribution throughout the body that we normally experience on Earth. And I believe that if we have normal physiologic experience, then I think that's health. That's the way our bodies is designed, so that's healthy. We wouldn't be able to simulate it entirely, but at least the standing upright and sort of draining the fluid from the cranium and off of those optic nerves and getting more normal distribution by the kidneys, all of these are going to go ahead and help. And also, I would mention that the centrifuge could be used for animal studies to begin to look at this issue of the gravity prescription, the artificial gravity prescription for healthy gestation and childhood. And then other parts of the habitat would be living rooms, living areas like bedrooms, living areas, as well as work areas. Now, after the initial habitat is set up, then more cargo deliveries would deliver what I call specialty Habs. And specialty Habs fall into different categories. And so you have the UniHab there in the upper left. You have utility Habs. These are like sanitation and recycling, sort of water processing sorts of things. Life support, certainly. And then processing Habs, these would be things like organic chemistry, and also the machining. You probably do outdoor metallurgy, but indoor machinery, fabrication, assembling of telerobots, these sorts of things. And then here to the left center would be an example of residential Habs, both private residence as well as sort of dorm Habs for international crew, but eventually a lot of private residence. And then food Habs, dining Habs, and what I call outdoor Habs. These are large habitats that are designed to look like they're outdoors. It's sort of like maybe have a jungle Hab or a beach Hab. And then here to the right is a centrifuge Hab, and the specialty Hab would need to be able to provide artificial gravity for a large number of people at the same time, and probably a way to be able to access that without having to shut down the centrifuge every time people want to get in and get out. And then here to the bottom left would be like fitness Hab, you know, sort of your fitness center to keep people healthy, keep that impact on the bones. Sports would be just amazing. You could literally fly inside a lunar habitat. And what I call performance Habs, these are things like music or dance. Dance in 1/6 gravity on the moon is going to be a totally new experience. It's going to be amazing as the world watches that. Bottom center is like medical Habs, and then bottom right, community Habs. We're talking things about meeting Habs, movie Habs, even church Habs, these sorts of things, as we're really beginning to develop a community on the moon and Mars. So after the initial UniHab, then I think the next step would be an interim step in which we have sort of one habitat for each category to illustrate the different categories of the specialty Habs. And then, of course, don't get overwhelmed by this, but this is sort of a grand, we do need a master plan, but sort of, you know, the green section is the agriculture Habs, the bottom right are medical Habs, upper left, those orange ones are the community Habs, etc., the fitness Habs, and the utilities as well. So one, I would love to really engage the architects at different university, or I think spacearchitects.com, get people together and say, hey, can we design a master plan? And then the Moon-Mars Analogue Base would follow this plan, starting small and growing larger over time. Okay, so I need to go ahead and wrap this up, and I wanted to go ahead and share with you. The question is, how quickly can we go ahead and construct this Moon-Mars Analogue Base? If we were to start with sheet plastic, I have quite a bit of experience with this. I developed a full-scale lunar lander made out of sheet plastic, you know, to illustrate it. And so this last week, myself and one other fella, in a period less than 24 hours, or let me say one day, we constructed the MiniHab. So what I did is I said, okay, the UniHab itself is rather large, 7,700 square feet. The MiniHab is just an example illustrating how easy it is to construct these mock-ups. And so a lot less involved, but doable. And so I designed the different parts that would need to be cut at the different dimensions. And this is what we constructed. And pretty proud that 2 guys in one day using sheet plastic and literally packing tape, it actually works very well. We were able to go ahead and construct this thing. And in 30 seconds using a large blower, we were able to inflate this thing. And we had indoor tethers to keep the roof relatively flat, with the idea that Telerobots would push Regolith on top. So let me conclude by just saying the Space Development Network, it is a co-sponsor of this Lunar Development Conference, and appreciate the opportunity to participate. It's an organization of space advocates collaborating with different other space advocacy organizations. It is free to join. We want people, but to stay a member, you have to be active. You have to actually do volunteer work to advance the plan for sustainable space development. I encourage you to go to DevelopSpace.info. This is an extremely extensive website, as much as 8 hours of reading material there on all sorts of aspects. And so I encourage you to go and check it out. It's well organized into different sections. I'd like to particularly point out there in the upper right, there's the International Lunar Exploration Phase, and in the center there is Achieving Earth Independence. These are 2 rather interesting and unique aspects of the website. And then we organize ourselves into working groups. We have probably about 8 or 10 different working groups right now. So if you would like to move things forward, I encourage you to go to DevelopSpace.info, check it out. If you're interested in it, go ahead and join, and we would love to get you involved. We would like to go ahead and partner with other space advocacy organizations to try to work together to advance towards our common goals. So working together to advance space development, that's the motto of the Space Development Network. And I look forward to starting this dialogue with space advocates, but especially the different space advocacy organizations, to say, is the Moon-Mars Analogue Base something that we would like to work together to go ahead and get started? So thank you for your attention, and I look forward to handling questions.
Yeah, thanks a lot, Doug, for that. And I could tell you at the Moon Society, one of our first projects when we were formed as an organization back in the year 2000 was something called Project Leto, which was our attempt to try to build an analog moon base as a tourist trap in Las Vegas.
Oh, cool.
Didn't get very far, but that was our idea back then. So we definitely are interested in working with you and the other volunteers at Space Development Network to see this happen in the near future.
Cool, sounds exciting.
So we've got quite a few questions, not a lot of time. Let's just rapid fire these. Hal Fluten asks, how much land would be needed for this analog base?
Good question. The analog base would grow. I'm going to say that that would need a few acres, probably 3 acres, something like that.
Okay. Melissa Roth, who's one of our keynotes tomorrow, Off Planet Research, asks, There are a variety of environments, including regolith soils on the Moon and Mars. How do you anticipate the analog bases will handle research and development across a range of possible landing sites?
So I mean, I actually advocate that let's go ahead and develop one site at the lunar South Pole initially. I've got sort of a specific location. But I think that on our website, we have a page dedicated to the telerobotic development of roads. And I think when you compact the dirt and sort of flatten it just a bit, just a very basic dirt roads, you can have self-driving, basically Cybertrucks carrying cargo and crew to any parts of the moon, in which case, when you establish those dirt roads, it's amazing. You now have, any part of the moon has access to the same resources within 3 days drive of any other part of the moon. And so I think that the regolith is pretty similar in terms of physical characteristics in different parts of the moon. So I think what would be done at the poles would probably be done at these other locations.
Mm-hmm. Michael Mueling asks, how are the analogs you're developing emulating the extended 100 Kelvin lunar night environment? Is the assumption, oh, go ahead.
No, go ahead, finish.
Is the assumption that they will have dense multi-gigawatt power sufficient to keep the entire habitat warm, including inflatable shell to prevent embrittlement?
Yeah, no, I think that first place, if we start at the poles, the temperature range is not so great as at the equatorial regions. However, probably far more important is when you are covering habitats with as much regolith as you need for radiation shielding for galactic cosmic rays, you're going to have a lot of insulation on top of you. And frankly, I think the concern isn't getting cold inside. I think the concern is rejecting the heat and having radiators. That needs to be designed into it.
Mm-hmm. JJ Hastings asks, how would you propose we transport the total gas mix at the required volume to inflate an entire habitat on Luna?
So I think if you have condensed air in cylinders, I mean like liquefied air, you may want, we can get access to a large amount of oxygen on the moon. There is nitrogen, the LCROSS results did show substantial amounts of nitrogen and carbon and nitrogen on the moon in the permanently shadowed craters, the ice there. However, there's not a lot of carbon and nitrogen. And so if you are producing propellant quantities of water ice, the side stream of the ammonia and the carbon monoxide and methane and these other things, ethylene is there as well, that you're basically replenishing losses, whether that's recycling losses or like airlock losses. And if we have to go ahead and ship nitrogen to make up for the losses, then I think that's just something that we would have to do.
Mm-hmm. Ben Stanley asks, are you familiar with Barbara Belvisi and Interstellar Labs? If so, how is your, you're not familiar? Okay, he was asking how is your vision similar?
Do you know about her?
No, I haven't heard of that before. Ben's got another question. Do you see any benefit to introducing additional stepping stones in harsh Earth environments? Rather than habitable Earth, Moon, Mars, maybe try habitable Earth settlement of high altitude, floating platforms underwater to Moon, Mars. The technical aspects would be really different in some cases, but we could learn a lot about the financial economic aspects.
Yeah, I'm myself, I think that we just need to focus on the Moon and Mars. The Moon is going to happen soon enough, and probably Mars is not going to be that much later. And so I think trying to work, especially in an underwater environment in an analog base, would be extremely expensive, dangerous, and just don't think, we're space advocates, we're just illustrating. And so that's the approach that I would use.
Okay.
Yeah.
Dana N asks, what do you think of Kimball Musk's Square Roots Grow, which is vertical farming in a shipping container?
Yeah, so and there's another space advocate who's advocating vertical farming. I think that is something that we should look at, because at the lunar poles, if it's sticking up, it's getting a lot of solar energy directly. I think that for radiation issues at the for the greenhouse, I think that might be problematic. I think there needs to be shielding, but I think that's a trade space that's open for analysis and discussion. Mm-hmm. Legitimate debate when it comes to greenhouses.
Rodrigo Romo from the Pisces team in Hawaii says
Oh,
aloha.
yeah.
He says, you guys met at ISDC last year, discussed Hawaii as a potential site for the analog base. Hank Rogers is working on this project.
Mm-hmm.
Have you contacted him at all?
I spoke with Hank at an ISDC, so got familiar. He's got an interesting approach. I think that I'm not too keen on being rurally located. I think there's great advantage to being close to populations. And so I think maybe we differ in terms of our approaches there. And also he's got a very interesting sort of robotic first approach. And I think there could be a fair amount of overlap there. So yeah, definitely dialogue, collaboration. You know, the Moon-Mars Analogue Base is not intended to make any other analog base unnecessary. I think of MDRS, for example, has done a tremendous amount of work, and I would like to steal everything that they learned that's applicable, take advantage of all the work that they've done over the years. It's pretty impressive, everything that they've done. Yeah.
Mm-hmm. Molly Kamenid asks, would you have to support the ceiling of the inflatable habitat to keep it from sinking in from the weight of the regolith?
Great question, but the answer is definitely not. You have 1/2 atmosphere, you have 5 tons per square meter pushing up. And the regolith, the weight is only 1/6 because it's on the moon. So you would have to have, I don't know, something like 30 meters of regolith to push, you know, to counteract. So frankly, you got to have those internal Kevlar tethers to keep this thing from wanting to turn into the sphere that it desperately wants to be. But great question.
Awesome. Okay, well, we're out of time and we have the noon hour starting for the networking sessions. Thanks a lot, Doug. This was a great presentation. And I just want to remind everyone, you can go into your Inventory app. There's 4 different networking rooms opening up right now. So you can meet other attendees and discuss some of the topics. I will be in the space business and startups networking area. So I hope to see you guys there. Thanks and have a great rest of your conference.